Now our topic is identification or calculation of biodiversity index from the plant matrix. Suppose a group of students went to Darjeeling and they uh, prepared a plant matrix. They took a part of conifer forest covers, and they took two species, that is pine species and cypress. Suppose this is the area they took. They divided the area into the grid. Suppose grid 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They prepared a grid and they prepared a matrix for the pine tree and the cypress tree. Okay. They conducted a field study for preparation of plant diversity index. They counted the number of cypress tree and pine tree. For pine tree, suppose for pine tree, they prepared a table, they prepared a matrix. Suppose I am taking only three grids, Okay, suppose for the grid number 3, number of pine trees is 7. For the grid number 5, number of pine trees is 8. And for the grid number 7, a pine tree is 1. And for the grid number 4, pine tree is 2. Number of pine tree is 2. For the grid number 6, pine tree is 5. And for the grid number 8, pine tree is 10. Suppose this is a matrix. Okay. And another matrix we prepared, a group of students prepared from their field survey, that is for the cypress tree. They prepared a matrix. Okay, for the grid number 3, number of cypress trees, suppose 5. I am taking all the number imaginary. Okay. Then for the grid number 5, and the number of cypress tree is 2. For the grid number 7, number of tree is 2. Grid number 4, number of tree is 2. For the 6, number is 9 and number is 12. So from this field study, student prepared these two metrics for the pine tree and the cypress tree. Now, question is, now how we will calculate the biodiversity index? Here we will learn all this process. As a student of geography, we can include another object like a slope object, landform object through this grid system. Okay. Here for the calculation of biodiversity index, we are following the method of Shannon-Weiner index. Shannon-Weiner index. Shannon index. We are preparing the Shannon index. Okay. For convenient, we are only taking a very small few species for the easiest calculation. Okay. Now this is one of our matrix derived from the field survey, and this is one of our plant matrix, and this is another plant matrix. Okay. Now how we will calculate the diversity index? Here for the diversity index, we are following the formula of Shannon. What is the formula of Shannon? We are taking the Shannon formula, very easiest way, very simple way. The basic for Shannon formula is, basic of the Shannon formula is A is equal to minus summation P1 into IN into Pi. This is the formula of Shannon index. Okay, we used this formula and we will calculate the biodiversity index. Okay, so we are last class I have told you, from any kind of any set of metrics anyone can derive the biodiversity index. Here for the convenience, we are preparing the calculation table. Suppose this is the category is cypress tree and pine tree. Okay, and we are taking only the first row for the cypress tree, 5, 2, 3. For only the first row for the pine tree, 7, number of pine tree, 1. Okay, so we are calculating the index, biodiversity index. Suppose that was the grid That was the grid zone. We are on, suppose this one we are taking 3 grid, we are taking 6 grid for calculating the biodiversity index. We are only taking these 3 grids. Okay, first row for the cypress tree, this row, this one, and first row for the pine tree. Suppose then how we will calculate the Shannan index? It is very simple index. Most of the ecologists used it. It's this index started near about 1948 by the ecologist. Okay, even for the plant species, even for the animal species, insect species, this method is used. This is the given data set. From this given data set we have to calculate the Shannon index with the help of this formula. Okay, what is P? First you have to know what is P. P is to number of individual species. Okay, number of species, number of individual species, number of individual species. It's like cypress tree, pine tree, so on, individual species. And T or capital P is the total species, okay, total species. And this is summation, this is the overall total of all PI. And what is IN? IN is near to you, IN is the natural logarithm. Okay, it's called natural logarithm, natural log. Okay, so we have to identify the P1, then total number of species, then natural log. Through these 3 things we can calculate all these things. Okay, for calculation we have to prepare a table. So for this calculation, for this index, Shannon index, we have to prepare a table. Okay, first thing is P1. First thing is P1. Then second column is P1 by capital P. Rather N, you can write down N also. You can write down N. N is the total number of species. Then this is the column number 1. This is column number 2. The P1 is the individual species, here the cypress tree and the pine tree. N is the total number of species throughout the whole region. Then that is P1. This is P1. A natural log into P1. Then third column is natural log into P1. Then fourth column is Pi into natural log into P1, and fifth column is negative. Okay, here you put a negative. Okay, a negative symbol, negative P1 natural log into Pi. Okay, this is very easy formula. Okay, first from that given matrix we have to identify. First thing is that the T, that is total number of plant, overall total number of plant. It is sometimes defined by N, capital N, sometimes it is defined by the capital P. Okay, so you have to add all these things through the help of calculator. 5 plus 2 plus 2 plus 7 plus 8 plus 1. So total number of tree is 25. P1 is the individual plant species. I have told you that P1 is the individual plant species. So for that, for calculation of this one, for calculation of this one and this one, we have to separately call all these things. Okay, For if this is 5, this is 2, this is 2. Okay, and same thing we have to prepare for the case of, here we are preparing for the case of cypress tree. Same thing will be, we will calculate all these things in the case of, we will calculate all these things in the case of pine tree too. Total number of pieces is 25. So T is 25. Okay. Then what we will do? 5 by 25, 5 by 25. Then you have to use the calculator. 5 divided by 25. That is 0.2. Then 2 divided by 25. That is 0.08. Then 2 divided by 25. That is 0.08. Then what is P? What is natural log into P? Then we can get the PI. This is the PI. We are getting PI. Then we have to identify the IN through the calculator. In calculator, there is a button that is IN. In each scientific calculator, through the pressing of this button, you can easily identify this column. You can easily calculate this column. Natural log into PI. This is the PI value 0.2. Then you have to press IN into 0.2 is equal to minus 1.61. Then press IN, then 0.8 is equal to minus 0.2, 0.5, 0.25. Then same, it will be same. Then so you can calculate the total number of species. Here for the cypress tree, we have write down the value of 522, and total number of species of cypress tree and the pine tree is 25. So we have divided all these individual, 5 divided by 25, 2 divided by 25, and 2 divided by 25. For next column, for we have to multiple IN with the PI value. This is the PI value. For the IN, through the help of calculator, we are pressing IN and then press 0.2 and then is equal to, then that will come. Okay. After that, you have to go for the third column. Third column is nothing but the multiplication of 2 and column number 3. Multiplication of column number 2 and column number 3. It is nothing but the multiplication of column number 2, column number 2 and column number 2. This is column number 2 and column number 3. This is PI, this is PI, and this is natural log into PI, and this one. You have to multiply this one to this one. Suppose to the help of calculator, 0.0 into 1.61. Then you have to 0.0 into 1.61. Then you have to write down minus 3.322. Then 0.25 into 0.08. Then you have to minus 0.02 and 0.02. Okay. So basically, student have to do three things. First thing, you have to adding all the species, and you have to categorize to the one species. Take all these total species, 5 divided by 25, 5 divided by 2 divided by 25, 2 divided by 25, and then getting the PI value. Then through the help of calculator, you have to multiply the PI with the IN. IN is the natural log, and then you have to multiply the both columns, column number 2 to column number 3. Here, PI into natural log into PI, and you are getting this point. And this is the minus. Minus means just remove the minus value, and you have to prepare a summation. you can add all these things. Just remove the minus value, just multiplying by the minus. That then what will be the result? Minus will be removed, all will be the positive. And do the summation. 322 plus 0.02 plus 0.02. So what will be the result? The summation minus P1 into IN into PI is equal to result is 0.362. For the Cyphers tree, our Shannon index is 0.362. Okay, this is the simplest way to calculate the Shannon index. And similarly, you have to do all these things for the case of pine tree. Suppose number of pine tree is 7, 8 and 1. 7, 8 and 1. And you have to go for the PI. PI is the total divided by individual. Individual divided by total. 7 divided by 25, 8 divided by 25, 1 divided by 25. Then through the help of calculator, a scientific calculator, press this button, that is IN button, that is natural logarithm button, and you can convert all these things to the natural logarithm. And after conversion of natural logarithm, go for the fourth column. Fourth column is the multiplication of this one and this one, and all the value will come in negative. And after that, same formula you have to write for the fifth column, but putting a negative sign, because in this formula there is a negative sign, and all this value just remain same, but it will be converted into the positive value. Then after the adding all these things, the result will come. For the Cyphers tree, the biodiversity index is 0.6362, and for do similar calculation for the pine tree, and the value, similar a value will come, and both are the biodiversity index. You can calculate separately the biodiversity index for the individual species. It is for the Cyphers tree, and another will come from another value will come, that will be the value for the pine tree. Okay, so maximum value of Shannon index, I think it is very easy to calculate. I will provide one or two small sum, and you will practice according to your own way. Okay, basically a Shannon index is most of the cases ecologists are used this formula randomly. Okay, maximum range 0 point Shannon value, maximum range for Shannon index varies from 0 to 3. Or if higher the value, if the value is near about 3, higher the value, lower the diversity. Higher the value, maximum value will be 3. Range of Shannon index is 0 to 3. Higher the value, lower the index. Okay, lower the value, higher the index. If this part for the interpretation, lower the values, higher the index. Most of the cases, rather all the cases, Shannon value varies from 0 to 3. Okay, and 0 to 1.5, this is called as a low Shannon index. 1.5 to 2.5 is called medium Shannon index, and 2.5 and above is called higher Shannon index. Okay, on the basis of calculated value, you can say that zone is a highly diversified in plant index or not. This value will depend on the range of the index. Okay, and another thing is that what is Shannon index? It's a quantitative measurement of biodiversity index to the quantity, to the number, to the numerical value. It is a quantitative measurement. Okay, it's a quantitative measurement. It's a quantitative measurement. And it this indicator, if the indicator measures, its indicator measures but biodiversity index signify that how many different type of species, how many different types of species, how many different types of species, how many different types of species are in your data set, your data set. Okay, this is the basic principle of Shannon index. How many different types of species, how different types of species are in your data set. And biodiversity, it's measured the biodiversity in richness or evenness or dominance, richness or evenness, richness or evenness. This is the basic thing of Shannon index. I think it's very easy to calculate, most widely used, and geographer use this indicator with the superficial attributes which include a slope, relatively dissection index of the grid area, then compare the biodiversity index. Okay, thank you very much.